Alright, so I'm going to go over the back page of the Geologic Sequences worksheet. This side of the worksheet was definitely trickier, but still very doable using your note sheet. As long as you have those note sheets and you have a good understanding of the principles, the definitions, you should be fine. Now for this side, you will also need to look at your time periods. So make sure you're looking at the back of the note sheet where we have our different time periods, eras, and eons. The first question starts off with an unconformity. Remember, an unconformity refers to erosion, or sometimes we would say a break in the rock record. The unconformity here is this wavy line between the limestone and the sandstone. In order to figure out what type it is, we look under the erosion line. That's always the clue for what type of unconformity you're looking at. Here we see sandstone, we see limestone, we do see an igneous rock here as well. They're all horizontal to the erosion. So this is going to be a disconformity. So a disconformity simply means that the erosion is horizontal with the rocks, and they're all sedimentary rocks. The other two options aren't correct because with an angular unconformity, the rocks are angled under the erosion. And these are not angled under the erosion, they're angled with the erosion. And with a nonconformity, we know a nonconformity is not going to be the right answer because underneath that erosion surface, it would be something that's not sedimentary. Nonconformity, not sedimentary, maybe igneous, maybe metamorphic. There is an igneous rock down here, but it's not the one that's directly under our erosion. So this is a disconformity. It says list the sequence of events from oldest to youngest. Include the processes. There's 6 total. You can see there are 5 letters over here. So those 5 letters are obviously going to be included in this story. And then there's one more thing. Now a few of you added in that there is this blank space. That doesn't count as a process. But the fact that they all tilted is a very real part of the process. So that'll be our 6th option, this tilt. Now all the layers are tilted together, so we're going to assume that they all tilted after they formed. You might think that D is an intrusion, but it has a horizontal line with C, meaning that it didn't intrude into C, it was there before C was deposited. Most likely it's going to be a lava flow, and the shale, the mud that formed the shale, settled out on top of the lava flow. So the oldest is going to be at the bottom, and that is D. Next will be the shale, which is C. Then our sandstone, B. We have to choose between our erosion and our limestone, but we know erosion happens before the next layer is put on. So E, the erosion is going to be next, and finally A, our limestone. So we have a sequence here. The whole thing got tilted at the end. You know it got tilted later because these layers are all tilted at the exact same angle. So for processes, we have 2. We have the tilt and we have the erosion, but the erosion is listed as E. And some of you went through and you wrote deposition, or crystallization, deposition, deposition, and that's fine. These layers were either crystallized or deposited. But when I said processes, I really mean things like erosion or tilt or fold, not just the basic deposited. The next one says if layer B is Ordovician and C is Cambrian, what's the age of layer D? So if I go over here and I look, if B is Ordovician, C is Cambrian, so Cambrian came before Ordovician. I'll go back and look at my time chart. I'm trying to figure out what came before the Cambrian. On my times chart, Cambrian's here, Ordovician here. Ordovician is younger, more recent than the Cambrian. Well, that igneous rock at the bottom is even older. So for time period, I'm going to go with Proterozoic. The Proterozoic happened before the Cambrian, before the Ordovician. So I have Proterozoic down here for D. By this, if it is Proterozoic, Cambrian, Ordovician, and if A is Mississippian, it's a very long word, that erosion happened somewhere between the Ordovician and the Mississippian, but it most likely happened just before the Mississippian, because everything between the two is erased. If the erosion had happened during the Ordovician, then we would start seeing the next time period, but we don't. So if we look at our chart, between the Ordovician and the Mississippian, we've got the Silurian and the Devonian. Since we don't have any rocks from the Silurian or the Devonian here, we're going to assume that the erosion happened during the Devonian and then the Mississippian got laid on top. So the best answer here would be the Devonian. However, a geologist could argue there might have been some during the Silurian as well, but we'd be looking for a little more evidence to back that up. So this is how you would answer questions 13 through 16 on the sheet. Moving down to the last sequence. Sequence 5 was the most complex. Alright, so it says what type of unconformity is represented by letter E? E is, again, it's this erosion line. Every time you have an unconformity, you know there's a break in the rock record. We're trying to figure out what happened below the erosion line. Nonconformity means below your erosion is not sedimentary. Maybe igneous, maybe metamorphic. Angular nonconformity means that the layers underneath are angled up toward the erosion. That's what we see here. Disconformity, remember, means all the layers below the erosion are horizontal. So in this case, we are looking at an angular unconformity. What principle of relative dating allows you to say the sequence represented by layers 1, 2, 3, and 4 was deformed after they were deposited? To answer this one, you need to look back at your note sheet where you filled out all the answers about the geologic timescale. And if you do that, what you'll find is that originally these layers would have been laid down horizontally. They aren't horizontal anymore, they're at an angle, but the principle that we would use to explain this would be the principle of original horizontality. That principle, original horizontality, often goes along with the angular unconformity. Because if you have a situation like this, I'm probably going to ask you, how do you know that they formed before they got angled? I may actually ask you about the previous sequence as well, where you saw these layers. And I may say, how do you know that these were tilted after they formed? You'd say, oh, well, the principle of original horizontality. Sediments are laid down flat. And if you see them at an angle, it happened later, maybe through plate tectonics, maybe through an earthquake fault. So back to sequence 5. We have 10 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we only have to add 1. That 1 is going to be the fact that these are all tilted. What happened after 1 through 4 formed. So the oldest here is going to be number 1, 2, 3, 4, and then they all tilted, and that's our process. And then E, which is the erosion, the unconformity here, that's another process. And then we just go from the bottom to the top. So D, C, B, and A. Pretty simple when you break it down like that. Now we're going back to time periods with the next. If layer C is Mississippian in age, what's the age of layer D? So C is Mississippian. We have to go back to our time scale and figure out what comes before Mississippian. Well, there it is, Devonian. Once again, Devonian is going to be our answer because it comes before the Mississippian. So twice I've asked you this question about the Mississippian, and twice the answer has been Devonian. Now, if we want to keep going with it, that's our Devonian, Mississippian, Pennsylvanian, Permian. I didn't ask you to do that, but it's always good practice just to kind of look at the time scales, see how they all fit together. Everything you see here, Devonian through Permian, represents a time before dinosaurs. This is all Paleozoic. It says, what are the ages of layers A and B? I already did that because I just went through the process. So B is going to be Pennsylvanian and A is going to be Permian. Remember, the Pennsylvanians, when our coal deposits formed, the Permian was when the largest ever extinction, 90% of life went extinct with the Permian. Finally, it says, who's the father of geology? You should have gotten that from your note sheet. The name of the father of geology is James Hutton. And I'm the mother of geology, Kelda Hudson. Let me know if you have any questions. And be sure you can do these skills before the unit test because you'll definitely be tested on them.